All right, guys, so we're continuing with Chapter 3, and these examples right here are going to kind of prep you for the second homework, which is not just things dropped from a height, but things that are actually thrown upwards, and then gravity, the acceleration of gravity takes over. So all these objects, by the way, are still considered to be in free fall, whether you drop them from a stationary position. Oh, don't want to do that. Drop them like a ball from a stationary position and it drops straight down. Of course, that's in free fall. But also, if you throw something up in the air and then gravity takes over and brings it back down, that's also considered to be in free fall as well. No matter what direction it's moving, as long as it's under the influence of gravity, we call that in free fall. So we did these two, we did this first one right here in class. But just for kind of, I don't know, review sake, I'm gonna do it again real quick. All right. Find the ball's velocity after 2 seconds and 7 seconds. All right. Well, it's thrown upwards, and by the way, the assumption is, and this is kind of dumb actually, but we're assuming, because we're not told otherwise, that the person is like laying on the ground and throwing the ball straight upwards. That's a person laying on the ground right there. Yeah. All right. So they're throwing the ball straight up. So there's a person's eye. Now, usually, if you're standing up, you're some distance off the ground when you throw it. But since we're not told otherwise, it's just simply thrown upwards, we'll say from the ground. Then we're going to assume they're laying on the ground right there. All right. And I'll tell you why in just a second. So the ball's velocity after 2 seconds and after 7 seconds. All right, well, what do we know about this ball? The initial velocity, this is thrown upwards, initial velocity equals 40 meters per second. Okay, the acceleration is going to be negative 9.81 meters per second squared. The time is going to be, well, there's 2 times. First time here is 2 seconds, and the final velocity, we'll say, final velocity 2 seconds, we don't know. All right? Oops, erase that. Final velocity equals, we don't know. Well, we do know what it is. We have an equation for final velocity. In fact, this is going to get in the way right here. Final velocity at 2 seconds equals initial velocity plus acceleration times time, in this case 2 seconds. So it's simply going to be our initial velocity, 40 meters per second, plus our negative 9.81 meters per second squared times 2 seconds. All right? All right, so 40 plus 9.81 times, or negative 9.81 times 2. So that's going to be our final velocity at 2 seconds is going to be 20.38. I'm going to round it to 20.4 meters per second. So that's a positive number. So at this point, the ball is still going up in the positive direction. But we know that given a long enough amount of time, gravity is going to take over and start bending it back downwards. So let's find out what the final velocity at 7, that's a 7 right there, at 7 seconds is. Well, we know it's still initial velocity plus acceleration times time. All right, initial velocity stays the same. Acceleration is going to be the same. Time is just going to be different. So that's going to be 40, for the sake of space, I'm going to leave out my units, plus negative 9.81 times 7. All right, 40 plus negative 9.81 times 7. All right, so that's our final velocity at 7 seconds is going to be negative 28.7 meters per second. So by this time, it's actually reached its peak and it's coming back down and is now coming down at 28.7 meters per second. So the second part right here, we just started to get to in class and didn't really didn't get a chance to start. This is where we're really picking up fresh right here, is find its height after 2 seconds and 7 seconds. That's why I said we really needed to identify, well, where is he starting from? All right, well, we're not told that he's starting from any height off the ground, so we can only assume he's laying on the ground. So we're assuming that this is thrown from ground level. All right, so find its height. That is, well, how high off the ground is it after 2 seconds and 7 seconds? Well, we have to know where it starts, so we're going to assume that it starts right from the ground. Most people don't throw balls or any kind of object right from laying on the ground, but we're going to assume this guy is. All right, so I'll draw this again. There's a ground. There's this guy or girl. They're laying on the ground, throwing a ball straight up in the air. All right, so the height off the ground at 2 seconds and 7 seconds, what is it? All right, well, the height is the displacement. All right, or we could really say it's the final position. That's actually more accurate. The final position, that's the height right there. We can only assume that the initial position is, well, at the ground, 0 meters off the ground, because we're not told otherwise. All right, he's not standing 4 feet off the ground or anything. So this is going to be assumed to be our initial position right here. We're simply going to find our x, or you know what? I'm so used to doing x's. These aren't x's, they're y's, right? They're y's, so, oh, for Pete's sake. I'm trying to erase that, and it does not want to erase. Nope, it's not erasing. I'm going to take this and, well, I'm just going to cross it out because my erase function is not going to, in fact, I'll just write right over it, sorry. All right, it's a big old Y right there, and that's a Y there, and that should be a Y because we're looking at the Y direction. Sorry about that, I'm used to writing X's. So we want to find Y final at 2 seconds, and we want to find Y final at 7 seconds as well. All right, what is the actual displacement right there? Or I'm sorry, what is the final position, the actual height? All right, well, we know that, I'm going to divide it up. Well, I won't do that quite just yet. We know that our initial velocity equals 40 meters per second. We know our acceleration is going to be negative 9.81 meters per second squared. And we know the time, all right? Time equals 2 seconds for our first scenario right here. All right, so that's a VI right there. That didn't come out very well. So our displacement, that is our final position right there, what equation could we use? Well, we have this equation. We have the delta y equals initial velocity times time plus 1/2 acceleration times time squared. All right, and we know the change in y can be y final minus y initial. Since our y initial, since this right here is 0, we can plug it in, but it wouldn't really do any help to add this y initial to the other side because it would just be 0, but we'll do that anyway. So initial velocity times time plus 1/2 acceleration times time squared. All right, so this is really y final equals y initial, which is going to be 0, plus initial velocity times time plus 1/2 acceleration times time squared. All right, I'll just do this calculation twice for 2 different times to get our 2 different values right here. All right, so that is 0. So we simply plug in for other values right there. All right, so y final 2 seconds is going to be, what's our initial velocity? 40 meters per second times 2 seconds plus 1/2 times negative 9.81 times 2 squared, right? 2 seconds squared. So let's see, 9.81. I get y final 2, that is its final height after 2 seconds is 60.4 meters. It's 60.4 meters off the ground. All right, that seems pretty high. Somebody threw it pretty high off the ground. All right, but we're going to see where it is now after 7 seconds. After 7 seconds. So we'll plug everything in again. Y final at 7 seconds equals initial velocity, that's 40, times 7 plus 1/2 times negative 9.81 meters per second squared times 7 now squared. All right, y final at 7 seconds. What is that? So I'm going to have to key this in myself. 40 times 7 plus 0.5 times negative 9.81 times 7 squared. That's 49, right? Times 49. This is at 39.7 meters off the ground. So just like in the last part of the problem, it's coming back down right here. Right, the first part, the initial velocity, for the velocity at 2 seconds is still going up. The velocity at 7 seconds is coming back down. Here, at 2 seconds, the position is high, and at 7 seconds, the position right here is much lower because the object is coming back down. All right, I'm going to stop the video right there for now because we've hit about the 10 or 11 minute mark, and I'll pick up with the next video so you can watch these in more bite-sized chunks. I'll see you on the next one.